Okay, let's look at a function. And it is f of x equals 2x squared plus 9x plus 9 over 3x squared plus 16x. I'm sorry, that's a minus 16x plus 5. Okay, so there's our function. And we're asked to find the x-intercept, y-intercept, vertical asymptote, and horizontal asymptotes if it has them. So let's start with probably what would be the easiest thing to find to start with would be the y-intercept. Now some things to remember. The y-intercept is where x equals 0. So that means I'm going to plug 0 in for all my x's. So for my y-intercept, I'm going to plug 0 in everywhere. Oh, that should be a 2, not a 3. Everywhere I have an x. And as I said, this is probably one of the easier ones to find. Minus 16 times 0 plus 5. So these all end up being 0 because 0 times anything is 0. So I'm left with 9 over 5. So it looks like my y-intercept is 0, 9, 5. Okay, let's look for the x-intercept. X-intercept. Now the x-intercept is where my y equals 0. Okay, so that time, I'm going to go ahead and erase this. And we'll find our x-intercept here. This time, I'm going to set this equal. It's going to be equal to 0. So I have 2x squared plus 9x plus 9 all over 3x squared minus 16x plus 5. Now one thing we want to think about also, we might actually be able to cancel some things out here. But again, we're just looking for the x-intercept at the moment. So we could do cross multiplication, which is this times 2x squared plus 9x plus 1 times 1, and then 0 plus times 3x squared minus 16x plus 5, which is going to be 0. So I'm going to have 2x squared plus 9x plus 9, and that is times 1 equals this 3x squared minus 16x plus 5, and that's going to be times 0. Well, anything times 0 is 0. So now I'm looking at this 2x squared plus 9x plus 9. It's a quadratic, so how do we solve quadratics? Well, we conceive it a factor. We can use quadratic formula. I believe this is factorable. 2x times x gives me x squared. And then, since they're all pluses, my signs are all going to be pluses. Now, 9, I can get that by 1 times 9 or 3 times 3, but I'm going to want, let's try 3 and 3 and see if that will give me my 9x. And I believe it will, because if I do 2x times 3, that's 6x, plus 3x is 9x. So that is it factored. Then we're going to set each one of those equal to 0. And it looks like I get 2x equals negative 3, x equals negative 3 halves, and x equals negative 3. So I have two x-intercepts. One's at negative 3, 0, and the other one is at negative 3 halves, 0. All right, so the last thing is finding the vertical asymptotes. So let's look at that. Let me see if I can clear my page here. Now that I have some more room, so we found our y-intercept, we found our x-intercept. Now we want to find our vertical asymptotes. Vertical asymptotes. Now when I'm looking for a vertical asymptote, I'm going to look at my denominator right here. Okay, because that's where I'm either going to have a vertical asymptote or possibly a hole in the graph. So I'm going to look at that 3x squared minus 16x plus 5. And we want to know where that equals 0, which happen to be our x-intercepts. If you remember, we factored this already, which was 3x, x, minus. Actually, we did not factor this. We factored the top, or the numerator. But we need to factor this, 3, and we'll figure out which one of these will give us 16, which I believe it'll be this one, because that'll give me 3 times negative 5, which is negative 15, plus a negative 1x is 16x. So that we did factor it appropriately. And I have 3x minus 1 equals 0. X minus 5 equals 0. Add 1, add 1. We're solving for x is what we're doing. Divide by 3, so I get x equals 1/3. And here we add 5 to both sides, and I get x equals 5. So it looks like I have two vertical asymptotes. I have one at x equals 1/3 and at x equals 5. So we have two of them right here. And then last but not least, we're asked to find the horizontal asymptotes. Now there are rules to finding the horizontal, and you look at the degrees between the numerator and the denominator. So if we look at the numerator, the highest degree here is a 2, and the highest degree in the denominator is a 2. So they're equal. If the degrees of the numerator and denominator of the leading coefficient are equal, then the horizontal asymptote is the ratio of the leading coefficients. So I look at these two coefficients, and it's the ratio. It's 2/3. So y equals 2/3 is our horizontal asymptote. If the degree of the denominator is greater than the degree of the numerator, then we have a horizontal asymptote at y equals 0. If the denominator is less than the numerator, then there aren't any horizontal asymptotes. So those are three good rules to remember when dealing with horizontal asymptotes.